So imagine the following scenario. I receive an email from a student, and they send the email, first of all, from a personal email address, from a Gmail account, rather than from their official student account with the school. Now, they've actually added a subject to their email, which is always a great idea. Emails without subjects could usually be sent to your professor's spam filter, so just be aware of that. And I open up the email and he says, "Hi, Professor. I was in your Math 97 class. I was wondering if you'd write me a letter of recommendation for a scholarship. Thank you, Mark Brown." Now, at the moment, this is the entirety of the information that I have received from Mr. Brown. And so I'm going to go and I'm going to look up his academic record just to see what I am working with. I do tend to teach quite a large number of Math 97 students, and so I'm not quite sure who this individual is. I don't quite remember the scores that he's received on the exams, so I'm going to go back and I'm going to look it up. Now, here's the thing. Our school is relatively small, but as it is, we have, roughly speaking, 10 to 15,000 students enrolled at any given time. And our academic record system also includes records from graduated students. So if I'm going to go and look up Mark Brown's transcripts, have a guess how many results I'm going to get back from our system if I search by his name. Now, it turns out it's not as bad as I thought it was. I got 11 academic records returned. But even though that's not as bad as I thought it was going to be, it's bad enough that I can't pin down which of the records belongs to the person who sent me the message. How am I supposed to know which of these 11 transcripts belongs to this Mark Brown? There would be a problem even if there were only 2 transcripts returned by our system. I would need some additional information to pin down which one is which. Now, in the case where there's no ambiguity at all, in the case where I input something into the system and exactly one unambiguous choice of record returns to me, that is the ideal situation. And we give that a special name, and we say that that's a situation where you have a function. So we say that y is a function of x if I can input x into the system, into the machine, into the formula, if for every x I input into the machine or formula or whatever I'm dealing with, there's never any ambiguity about what comes back to me. At most one record, one number, at most one y is returned / yielded by this machine, by this formula, by this rule. This is the ideal scenario, especially if you're working with computers, because computers really do a bad job with ambiguity and with choices. Now, if you're in this scenario, there's some shorthand for y is a function of x, and that's the letter y equals sign for is, f for function, and then a parenthesis surrounding the input letter x, y equals f of x. Beware, this is not f times x. This is not meant to suggest that f and x are being multiplied together. This notation is meant to feel a little bit like this image right below, kind of like a search box. In this image, which I took directly from our academic record system, it's allowing you to search by student ID. So student ID is indicated next to the search box as a kind of name or title. Then the search box itself is where the input goes. And then you hit the magnifying glass and the result comes back. So just be on the lookout for that. X is the input. This is what you're putting into the computer in the input box, represented by the parenthesis. F is just the name or title of the function. Some descriptive title, usually F just for short. And Y is standing for the quantity that is yielded or returned by the function. Input X, output Y, parenthesis, input box. F is just a name, title, nickname for the function. Okay, let's test this definition. Suppose that I give you a little table, real small, for some paired values of X and Y. -1, 0, -1, 2, 3, 4. Is Y a function of X in this relationship? Well, imagine that I entered in X equals -1 to this machine here. The machine would not know whether to return Y equals 2 from this first entry in the table, or Y equals 4 from the second entry in the table. So there's an ambiguity here. There's a single input that's trying to yield back two different outputs. So I would say no, Y is not a function of X. And order really does matter here. The one after of is always input. The one after of is input, and the one before of is output. I change this table just a bit. Really flip the values of X and Y from the previous example. What about this case? Is X a function of Y? What do you think? Well, if I enter X equals 2, the system knows exactly what to give back to me. Enter X equals 2, it returns Y equals -1. If I enter X equals 3 into the system, the computer knows to give me back Y equals 0. There's no question. And if I enter X equals 4, it knows to give me Y equals -1 in return. So in this case, where there's a duplicate in the Y's position, that's not creating any trouble at all. Yes, Y is a function of X. Let's try a graphical version of this. Suppose that I came in and I gave you this graph to represent the pairs of X and Y's. And I said, is Y a function of X? Take a moment. What do you think? Well, no matter what X I pick, there's always a single Y value that's associated with that particular X. I can go up or down and find a single Y value that corresponds to any X I want to choose. Because of that, Y is a function of X. And compare that with the same graph, just tipped on its side. Is Y a function of X? What do you think? Well, now I think there's a problem, because if I choose an input X value right around here, then there's an ambiguity about which Y value goes with that. This particular X is associated with two Y's, one positive and one negative. And because of that, because there are two Y's corresponding to this single X value, I would have to say no, y is not a function of x.